Welcome to the experiment 1 of ARM microcontroller lab. This experiment demonstrates use of arithmetic instructions. These are the steps for this experiment. Before doing the experiment, we should have the knowledge of the ARM instruction set, particularly the data processing instructions. These instructions are command to the CPU to perform certain actions such as addition, subtraction, multiplication. Particularly, the data processing instruction used in this experiment are multiplication instruction, that is mul RD. It multiplies the two operands and the result will be in this destination register. And compare, subtraction and conditional branch instructions are used to implement the loop to perform number of iterations. To write ARM assembly program, we should know the ARM instruction set as well assembler directives. The assembler directives are instruction for the assembler to perform, to assemble the instruction, to link the instructions. Assembler directives are commands to the assembler. These are also called as pseudo instructions. Here a directive used to specify the location in the memory, and any application in the ARM should be placed between the entry and end directives. The data reservation directives are used to place the necessary data in the memory, and these data are used during the program execution. DCB is a data to reserve in the byte size, and this is the directive to reserve the data in the word size, and this is the data to reserve the array of words. And space directive reserves a 0 block of memory, and thumb directives are specifically used when the both ARM and thumb instructions are used in the program. Export and import directives provides the binding between the different modules. Knowledge of writing assembly programming is very important for this experiment. The structure of the assembly program starts with the area directive, which specifies the location where the program has to be placed in the memory. This area starts with the keyword area and the name of the section, which can be specified by the programmer, and it says the code section. The code section should be read only. Then the program should be begin by the keyword called entry and end by the directive end. The in between, the set of instructions are specified to define the functionality or define the logic. Each instruction having these fields, the label field which holds the address of the instruction, and it can be user defined or any name you can specify, or it can also be a blank. The opcode is a mnemonic or instruction like add, add, sub, and the operands are, it can be 3 operands, 2 operands, depends on the instruction format, syntax. Commands helps you to read, understand and document the program, but have no effect on the object code. To do this experiment, we should have the knowledge of IDE. Particularly in this experiment, we have used the Keel Microvision IDE. This is a tool which is used to edit, compile, link, debug the assembly code. The last very important point, we should know the equation, how to find the factorial of the given number. Algorithm for finding the factorial of a given number is, we have to specify the n and the factorial of n are allocated to the register R0 and R1 respectively. R1 is initialized to 1 to make sure that 0 factorial equal to 1. And To implement the equation of the factorial equations, we have to use the multiplication and the decrement the n value by using the decrement instruction, and then repeat this iteration by using the branch and compare instruction. So let us see the coding by referring the flow chart. The first is we have to specify the area, the location, and the name of the location we specified as a fact, and it should be read only, and the program is begin by the keyword entry, which is the directive, and the first instruction is we have to load the n value into the R0, and then the R1, which is the register which holds the result of factorial, which is initialized to 1, and to perform multiplication and subtraction to perform the decrement of n, and repeat this decrement and multiplication repeatedly till the n or content of the R1 should be 1. Once it reaches the value 1 and the end of the program. So these are the steps for debugging. So let us see how creating the project, executing the program. Open the tool and creating the new project. You have to specify the folder. The best practice is you can give the specific folder for your project. Give the name for the project. And specify the target. So in this we are using the LPC2148, which is ARM7 based microcontroller. Next, create a new file to write the code, then save it and give the file name with the extension of .a. And then add the created file by selecting the existing file source file. Then the source file is added into the project. Then you have to assemble or build. You can see the errors and warnings. There is 0 error. You can visualize the content of the register R0, because the content of the R0 shows the n value and the content of the R1 shows the factorial of the n number. You can do either single step or entire program. After execution, the result will be the 78, which is the hexadecimal value. The decimal equivalent of this value will be 120. Since we considered the n value as 5, in this program the n value is part of the program. Even you can modify this program such that the value of n and f can be accessed from the memory as shown here. To do this modification, you have to use the directive DCD to specify the n, which is n is a word, and initialize the value 5, and f, which is a factorial, which is initially it has defined as a 0. And the slightly modified in the program is we have to use the instruction LDR to load the address of N into the R2. R2 register is used as a pointer to the N address of the N, right? So what it will do is load the value of N into the from the memory into the register R0. And execution of this instruction we can see. Here the 5 which is stored in the location, and then after execution we can see the result in memory only. Since R2 is a pointer, so this is the address, and 78 is the value you can see in the decimal form also. Thank you.